Hi students, welcome to math class. In this section we are studying about Green's theorem for a plane. Okay, first we can study the statement of Green's theorem. Listen, if phi of xy, psi of xy, dou phi by dou y and dou psi by dou x be continuous functions over a region R bounded by simple closed curve C in xy plane, then we can define circular integral over C phi dx plus psi dy equal to double integral over the region R dou psi by dou x minus dou phi by dou y dx dy. Okay, please write down the statement of Green's theorem. I repeat, listen. If phi of xy, psi of xy, dou phi by dou y and dou psi by dou x be continuous functions, remember that these are continuous functions over a region R, then over a region R bounded by a simple closed curve C, bounded by a simple closed curve C in the xy plane, then circular integral over C phi dx plus psi dy equal to double integral over the region R dou psi by dou x minus dou phi by dou y dx dy. This is very important. This equation is very important. Remember that circular integral over C phi dx plus psi dy is equal to double integral. First you may find out dou psi by dou x. Here is psi, dou psi by dou x. That means you may find out the partial derivative with respect to x minus dou phi. Phi is here, dou phi by dou y. First dou psi by dou x minus second one is dou phi by dou y dx dy. Okay, this is the statement of Green's theorem. Please write down on your notebook. Now we can do some problems based on Green's theorem. Okay, first you may write this statement on your notebook. Our first question based on Green's theorem is this one. Please write this question on your notebook. Our question is, a vector field F is given by vector f is equal to sin yi plus x into 1 plus cos yj. Then evaluate the line integral over c f dot dr, where c is the circular path given by x square plus y square equal to a square. Okay, please write down. Our question is, listen. A vector field f is given by vector f is equal to sin yi plus x into 1 plus cos yj. F is given by this quantity. Evaluate the line integral over c f dot dr, where c is the circular path given by x square plus y square equal to a square. Okay. How to solve this question? First you may write this question on your notebook. Okay, we can do it. First it is given that what is our f? Our f is vector f is equal to sin yi plus x into 1 plus cos y j. Okay, this is given in the question paper. Vector f equal to sin yi plus x into 1 plus cos yj. Then we can find out integral over c f dot dr, vector f dot dr is equal to integral over c. What is f? F is sin yi plus x into 1 plus cos yj. This is our f. F dot dr, that is, here is a dot product, dot dr. What is dr? Vector dr is equal to I dx plus j dy. Okay. Now we want to find out the dot product. How to find out the dot product? Multiply with the corresponding I components. Here is the component of I is sin y. Here is dx. First these two, multiply these two terms, then multiply the component of j. Therefore it will become less than which is equal to integral over c sin y into dx, that is sin y dx, plus second one is x into 1 plus cos y dy, x into 1 plus cos y dy. Okay, therefore we get integral over c sin y dx plus x into 1 plus cos y dy. Now we are applying the Green's theorem. Remember that here sin y is our 5. Sin y is 5 and x into 1 plus cos y, that is our sin. Okay, remember that phi is sin y and psi is x into 1 plus cos y. Now we are applying the Green's theorem. Listen. Please write these steps. First we may find out f dot dr. F dot dr is given by integral over c sin y dx plus x into 1 plus cos y dy. Remember that sin y is our phi, x into 1 plus cos y is our psi. Okay, now we can apply the Green's theorem. By the definition of Green's theorem, we can write, listen, by the definition of Green's theorem, we can write circular integral over c phi dx plus psi dy is equal to double integral over s dou psi by dou x minus dou phi by dou y dx dy. Okay, that is equal to integral over s. What is our phi? Phi is x into 1 plus cos y. That is our phi. First we may find dou psi by dou x. Here psi is x into 1 plus cos y. Therefore dou by dou x of our psi. What is psi? X into 1 plus cos y. Okay, x into 1 plus cos y minus dou by dou y of phi. What is our phi? Phi is sin y. Okay. Into dx dy. Okay, into dx dy. Now listen. How to do it? Listen. That is double integral over s. Okay. X into 1 plus cos y. Find out dou by dou x. That means here we are differentiating with respect to x, taking the terms of y as constant. Okay. Here, therefore, d by dx of x into 1 plus cos y will become 1 plus the derivative of x is 1. 1 into constant, that is 1 plus cos y minus next dou by dou y of sin y. The derivative of sin y is cos y dx dy. Now listen, cos y minus cos y will become 0. The remaining is integral over s 1 into dx dy, that is dx dy, which is equal to, remember that double integral over s dx dy is equal to area of circle. Here, remember that this is our x axis, y axis. Then we can define a circle. Here A is the radius, here is O, here is x, and here is y. Okay. Area of the circle. We know that here radius of the circle is A. Therefore, area of the circle is equal to pi r square. R is the radius, but here radius is A. Therefore, pi a square. This is the final answer. Where remember that S is the circular plane surface of radius A. Okay. We are applying Green's theorem. Then we will get double integral over dx dy, which is equal to area of the circle. We know that here radius of the circle is A. Therefore, final answer is pi a square. Okay. Please write down on your notebook. Our second question is, using Green's theorem, evaluate integral over c x square y dx plus x square dy, where c is the boundary described counterclockwise of the triangle with the vertices 0, 0, 1, 0 and 1, 1. Okay. That is our question. Please write down this question on your notebook. My question is, using Green's theorem, evaluate integral over c x square y dx plus x square dy, where c is the boundary described counterclockwise of the triangle with the vertices. 3 vertices are given. These 3 are the vertices of the triangle. First one is 0, 0, 1, 0 and 1, 1. First we can draw a diagram. Here is our x axis, here is our y axis. Then we are describing a triangle. Okay. This line is y equal to x. The 3 vertices are 0, O, here is O and here is A, here is B. Okay. 3 points. First O is 0, 0, then the B is 1, 0 and the A is 1, 1. Okay, we want to integrate this one. This is the figure for this question. Okay, here is a triangle. You can see OAB with the vertices 0, 0, 1, 0 and 1, 1. Here is a line segment. That line is, the equation of the line is y equal to x. Okay. Now we can do this question. Listen, we are applying Green's theorem. Okay. Here remember that here our question is this one, integral over c x square y dx plus x square dy. Okay, x square dy. Therefore, here this quantity is our phi and this one is our psi. Okay, phi and psi. Phi is x square y and psi is x square. Okay, x square. Please write down. Please draw this figure. Now we can do this question using Green's theorem. Okay. Now we know what is the definition of Green's theorem. According to Green's theorem, we can solve this problem. First you may write this one. Okay, here is phi is x square y and psi is x square. Okay. Now we can apply the Green's theorem. This is by the definition of Green's theorem, we can write the circular integral over C phi dx phi dx plus psi dy by Green's theorem. Integral over C phi dx plus psi dy is equal to double integral over R dou psi by dou x minus dou phi by dou y dx dy. Okay, that is, here is integral over C x square y dx plus x square dy, which is equal to double integral over the region R. First, dou by dou x of psi. What is our psi? Our psi is x square. Therefore, dou by dou x of x square minus dou by dou y of phi. What is phi? X square y. X square y dx dy. Okay, which is equal to integral over R. Okay, dou by dou x of x square. That means you may find out the derivative with respect to x. We know that the derivative of x square is 2x. 2x minus dou by dou y of x square y. Here x square is taken as constant and y. The derivative of y is 1. Therefore x square into 1. That is equal to 2x minus x square dx dy, which is equal to this can be written as, now we may remember that here is our region is 0 to 1 and 0 to x. Therefore, this can be written as, which is equal to integral over 0 to 1 2x minus x square dx into integral over 0 to x dy. Okay, which is equal to integral over 0 to 1 2x minus x square dx into integral dy, that is y. Here is lower limit is 0, upper limit is x. First we may apply upper limit minus lower limit. Therefore, this term will become x. Y is replaced by x minus 0, that is x. Okay, that is equal to, remember that here is y, lower limit is 0, upper limit is x. Therefore, this term will become x minus 0, that is into x. Now we are multiplying x with this term. Okay, then we will get integral over 0 to 1 2x into x, 2x square minus x square into x cube dx. Okay, that is equal to 2x cube by 3, 2 into integral of x square is x cube by 3 minus integral of x cube is x raised to 4 by 4. Now we are applying the lower limit and upper limit. When we are applying the upper limit, this will become x is replaced by 1. Therefore, 2 into 1 cube by 3 minus 1 raised to 4 by 4. That is 2 by 3 minus 1 by 4. Minus, then we are applying the lower limit. Here is 0, here is 0. Okay. 2 times are 0. Therefore, our final answer is 2 by 3 minus 1 by 4, which is equal to, you know that it is equal to 5 by 12. 5 by 12 is our final answer. Okay, please write down. Remember that here is we are applying the Green's theorem. According to Green's theorem, circular integral over C phi dx plus psi dy equal to double integral over R dou psi by dou x minus dou phi by dou y into dx dy. Okay, here is this term is our phi and this term is our psi. Okay, therefore dou by dou x of psi is x square minus dou by dou y of x square y. Okay, when we are doing, we get the final answer is 5 by 12. 5 by 12 is our final answer. Please write down on your notebook. Dear students, our next question is use Green's theorem to evaluate integral over C x square plus xy dx plus x square plus y square dy, where C is the square formed by the lines y equal to plus or minus 1, x equal to plus or minus 1. Please write this question on your notebook. Okay, remember that use Green's theorem. We are applying Green's theorem to evaluate integral over C x square plus xy dx plus x square plus y square dy, where C is the square formed by the lines y equal to plus or minus 1 and x is also equal to plus or minus 1. Okay, please write down, then we can do this problem. Okay, this is very important, this one. Evaluate integral over C, this one. Okay. Now we can do this question. Okay, listen how to solve, evaluate this function using Green's theorem. Okay, listen. Okay, by Green's theorem we know that first we can write the question integral over C x square plus xy dx plus x square plus y square dy. Okay, here remember that this term is our phi and this term is our psi. Phi and psi. Okay, first one is our this one is our phi and this one is our psi. Okay, now by Green's theorem we know that circular integral over C phi dx plus psi dy, which is equal to, you know that this double integral over dou psi by dou x minus dou phi by dou y dx dy. Okay, now listen, which is equal to, when we are applying the Green's theorem, we will get minus 1 to 1 dou by dou x of psi. What is our psi? X square plus y square. X square plus y square minus dou by dou y of phi. What is our phi? X square plus xy. X square plus xy. Okay, the whole dx dy. Okay, That is equal to, listen, minus 1 to 1, minus 1 to 1. X square plus y square, you may find out dou by dou x of x square plus y square. We know that the derivative of x square is 2x. Derivative of y square with respect to x, y square is a constant, therefore its derivative will become 0. Therefore, here is 2x minus dou by dou y of x square plus x square, xy. Here x square is constant. We may find out dou by dou y. That means you may find out the derivative of x into y with respect to y. Therefore, that will become minus x into dx dy, which is equal to 2x minus x is x. Therefore, this can be written as minus 1 to 1, minus 1 to 1, x dx dy. Okay, that is equal to integral over minus 1 to 1 x dx into integral over minus 1 to 1 dy. Okay, dy. That is equal to, remember that, integral over minus 1 to 1 x dx, next is y, integral dy, that is y. We may apply the lower value and the upper value. Therefore, it will become 1 minus minus 1. It will become 2. When we are applying the upper value, 1 minus minus 1, that is equal to 2. That is, which is equal to integral minus 1 to 1. Here is 2 into x dx, which is equal to 2 into integral of x is x square by 2. We are applying the lower and upper value. 2 and 2 cancel. The remaining is x square. We want to apply the upper value is 1 and lower value is minus 1. 1 square, that is 1 minus minus 1 square. You know that minus 1 square is 1. That is 1 minus 1. That is equal to 1 minus 1. 1 minus 1 equal to 0 is our final answer. Okay, please write down. Remember that using Green's theorem, first we may find out dou by dou x of x square plus y square, then dou by dou y of x square plus xy dx dy. Okay, that will become 2x minus x. We know that 2x minus x is x. Then minus 1 to 1 x dx minus 1 to 1 dy. We know that integral dy is y. We are applying the upper value and lower value. Then we will get 1 plus 1, that is 2. 2 into integral of minus 1 to 1 x dx, which is equal to x square, 2 and 2 cancel, minus 1 to 1, that is equal to 1 minus minus 1 square. We know that minus 1 square is 1. Therefore, 1 minus 1, that is equal to 0. 0 is our final answer. Okay, please write down on your notebook. If you have any doubt, then please write in the comment box below. Thank you for watching. For more educational videos, please subscribe our channel. Please write these steps on your notebook.